All right, good afternoon, everyone. Hi, I'm Sean. Thanks for all coming on a Saturday. This was really good timing for me. I just finished a project, so I thought I'd try to share it with you, maybe get some feedback. It's about exploring electricity, latrine, and water access data in India. So I combined a lot of census data, cleaned it up, and visualized it in a Shiny app. So I thought I'd show you the project, get your thoughts on it, and then kind of just break it down, like how did I do it, what are each steps, how do all the pieces fit together. So has anyone, basically I'm using three main packages aside from the kind of normal tidyverse packages. Has anyone ever used the SF package? Has anyone used Leaflet? A couple people. And has anyone used Shiny? A couple more people. Okay, great. So let me just show you the project, and we'll go from there. So I recognize this is India, obviously. So this is a Shiny app. I'm running it locally, but it is hosted online, and I'll give you the link at the end of the talk. So this is plotting electricity, access to electricity in 2011, all households. So there's a lot happening at once. It was, I think, like almost too much happening at once, but I tried to communicate as much as possible without it being too much. But I guess when you look at like electricity data, any kind of development data, like it often lacks context. Like if I tell you that 70% of households in India have electricity, that doesn't tell you that much, because behind that single number there must be a huge distribution. Some areas of the country will be 100%, some areas will be 10%. So how does it average out to 70%? And you want to also know like over time, like what was it 10 years ago? Is that a huge, maybe 70% is a huge jump, so maybe actually they've made a lot of progress. And then you also want to know things like urban versus rural, like what are the kind of, like how can we cross-tabulate this figure? So that's what I've tried to do with all of this electricity, latrine, and water access data. So this is electricity. If you're on this side, it might be difficult for you to see the legend, but the bright yellow is 90 to 100%, and dark purple is like 0 to 10%, and the green is like in the middle. So brighter yellow means higher levels access to electricity. Purple is like lower percentage of whatever variable you're plotting. So we have options to plot. Go ahead.
So by percentage you mean the hours that they have electricity for?
So the data looks at number of households who have electricity.
Okay, it's the number of households.
So it'll take the total number of districts in that, the total number of households in that district, and how many of them have electricity. So it's not about hours. Yeah, and I'll get into more about like why I chose this data set. But first, let's just like look at everything you can do with this app. So there's electricity, there's latrines, if you have both electricity and latrine. So now it's changed to, these are households that have both electricity and latrine. So I think we were at 67%, now we're down to 40%. Kerala is still mostly bright yellow, but much rarer to have both things. So you can visualize all kinds of relationships if we wanted to see let's go back to, if you want to go back 10 years. So actually 10 years ago, for 2001, for some reason they collected the data differently. They only collected electricity and latrine. They didn't count both at the same time. So whereas 91 and 2011, you can look at both things simultaneously. 2001, you can only do electricity or latrine. But you can kind of see, the trend over time. So, so that's the map. Now I'll move to the histogram, maybe explain that portion. So this histogram is looking at, it's just counting districts. So in 2011, there's 640 districts, and the histogram basically counts the number of districts for any given percentage. So the most common, for this particular set of parameters, most districts are around, most commonly we have about over 30 districts in India that are around 20%, which have access to latrines. And you have very few districts that have very high levels of access to latrine. And there's weaknesses behind this histogram. For instance, the districts are of very different sizes. So you have some districts like Bangalore, which has a few million people, and you have districts like Ladakh, which have a few thousand, and they're all counted equally. So this is just counting number of districts. But this yellow line here is the actual all India percentage. So often it looks like a median, but it's not the median. So this is actually the all India percentage. So I'm trying to show both the distribution behind the single number, and we show that both in a histogram and geographically. So this is the spread in a histogram, but this is the spread, how that spread reflects geographically. Does that make sense?
Yes.
Okay. Anytime, just shout out.
From where did you get this data?
So this data comes from the Census digital library. So this is the Government of India's Census digital library, and if you go to the tables tab, you can choose all different kind of tables. And I was looking for a project. I didn't have any specific interest in this topic, but I wanted some kind of data set where I could track metrics over time and see a lot of context. So this is an incredibly rich data set. I mean, you can look at...
Did you find any missing value in the data?
It's, as far as the quality, it's pretty good. I'm sure the SocialCops teams works with much messier data, which is but the census data is pretty good. A lot of effort has gone into that, I'm sure. It's a bit arduous in that each year is different. There was a few mishaps here and there, but overall it's pretty good.
So what was your approach to impute missing values?
So I didn't impute any missing values. I think the only real missing data, well, I guess there's two kinds of missing data. So for instance, if I go to, this is 2011 scheduled cast. So we're just looking at scheduled casts here, scheduled cast households. So you'll notice that the Northeast is gray. So it's missing in the sense of it was implicitly missing. There's no data for that because there aren't scheduled casts in the Northeast. There aren't scheduled tribes in Punjab. So that was implicitly missing data that I had to add because it doesn't come up and just have a bunch of NAs or values. It's just not there. So you have to, if I didn't add that, then it would just be missing entirely from the map. But there are weird, if I go to, I think 1991, there's 40 districts or so that, if I needed 21 rows for each district, 21 different observations, 30 districts or so had 20 observations. They were missing one weird combination of scheduled casts with tap water and rural, one weird row. So that's there. So you might catch a few weird gray districts. And then Bihar scheduled cast, scheduled tribe data, I had the file looked like it was corrupted. I couldn't read it. So that's missing. And Jammu and Kashmir, there was conflict in 1991, so there's no data for that. And so aside from electricity and latrine, we can also look at water availability. So this is tracking water within premises, outside premises, near premises in some years. So this was pretty interesting, I think. So that's just another, it's the same kind of, mapping percentages, but with different data. And so there's all kinds of, things you can explore here. Water source was available, so if you were curious what percentage of households had tap water from a treated source, what percentage of households had an uncovered well, you can really, dive into different patterns. So I made some GIFs that kind of maybe show different ways of exploring data. So with this visualization, you can track progress across years. So these tags are moving to 91, 2001, 2011. So you can see electricity goes from around 40% to 50% and 60%. So you can see a couple things happening. One is the map becomes more yellow. The histogram shifts right. Even 2011 is really dramatic. Like it's really skewed left because more and more districts are increasing their access to electricity. And then in the bottom right, we have a line plot. So that's showing the progress over time, and the larger point moves with whatever year you're selecting. So that's like just one example. Another thing you can do is, I haven't demonstrated this yet, but you can track districts. So if you want more information on a specific district, you can click on that district, and it'll add a district and state information. So let me go. So let's say I wanted to know more about Jaisalmer. So now we've said that Jaisalmer has 17,000 out of 113,000. What the percentage is, it's added the state and the district intercept here. So Jaisalmer is performing below the state average and below the India average. The state average matches the all India, that's why it's covered up. But that's another thing, so you can check out different districts. All right. Another thing, comparing urban versus rural. So this is another real dramatic change. So it's moving from total all households, just urban households, and then just rural households. And you can notice the map is very different colored, and the histogram is really shifting. Like it's shifting from left skewed to right skewed, entirely depending on whether you're looking at urban and rural households. And the line plot is really, it's obviously much higher for urban households. This is mapping water available within households, within the premises. Another thing, you could look at SC and ST households versus all households. This one isn't as dramatic, but you can see that if you subset for SC households, for instance, it's lower than the total. So one other thing I haven't showed you that I'm also mapping household count. So one major weakness with the choropleth is that it conceals the number of households in each district. So I'm trying to combat that problem by mapping household count. So let me walk you through that. And you'll notice the color is different, and there's a reason for that. So, as I mentioned before, big metros, they have a lot of people in a very small district. So like Mumbai, Delhi, Bangalore, you can barely see them on the map. They don't stand out, but obviously a lot more people live in there than they do in, Ladakh. But Ladakh is, huge on the map. Jaisalmer is really big. These districts are big. But on the choropleth, like if I'm mapping percentages, everything is equal, right? And let's say if I'm filtering to really narrow categories, number of rural ST households who have covered wells within their household, or near their premises. Some districts might only have 5 households that fit that exact criteria, but on the choropleth, everything just it'll just map whatever the percentage is, so it can be a little misleading. So I've done, separately mapping. This is basically mapping population density to try to combat that, like to make you aware that these are not all equal divisions. So instead of the previous scale was just every 10 percentage points was a different color, now I have a logarithmic scale. Because if you look at the histogram, you'll see that this is highly skewed data. So you have mostly small districts, and then you have a few that are huge. So you kind of need a logarithmic scale. Hard to see from that side, but my scale goes from 0, 10,000, 20,000, 60,000, 160,000, 440,000, 1.2 lakhs. So that's, it's not increasing at a fixed scale, it's increasing at an exponential scale. Because otherwise, if I had done a fixed scale, basically the whole map would be one color, and then you'd have, those very big districts would be a different color, because it'd be trying to divide everything equally. And we can talk more about that problem later. And you'll notice Delhi is actually divided into, I think, 9 districts. That's what I was trying to show here. So New Delhi actually is its own district. It's a tiny little spot, which, at the zoomed out version, you can't really see. Okay. So any other question? I mean, I'm going to go into everything in more detail, but go ahead.
Yeah, so just as you were mentioning that there will be districts having high population density and ones having lower. So do you do any kind of weighting on basis of the population density?
Any kind of what?
Any kind of weighted average or any kind of...
No. So I'm just, visualizing the data here, so I haven't done any kind of, manipulation, any kind of modeling or weighting. I think depending on your question, that would be, and what you're trying to investigate, you'd maybe want to do some kind of weighted average. But instead, I have the real averages. So if you click on, electricity for a given district, the percentage for all India is 67%. For Jaisalmer, it's 38%. So you can get the actual numbers. So I haven't done, really my goal was just to visualize. So I haven't done any kind of weighting.
Can you show the data set?
The data set? Okay.
Sample data set. I want to know that what are the variables available in this.
Okay. So I'll come to that. So let me break down now the process of how I made it. Let's get to that part. So basically there's 4 main components. So the first is wrangling the data from the Census digital library. You have to start there. So you have to, I took probably a few hundred Excel sheets, and 1991 they're available as CSVs. So just basically combining them and putting them into a tidy format. And so for that we use dplyr, all the tidyverse tools, tidyr, all those kind of packages. Once you have that data, you need to make it spatial. So you need to join spatial polygons. So there's separately, I found on GitHub, I found the spatial data, which for each district it had basically the associated polygon. What does that shape look like? And then you join those two together. So I joined my census data and my spatial data together. Once you, and to do that, you use the SF package, which we'll talk more about. So that's for working with geospatial data. Once you have that, then you can draw maps. So with maps, I'm using Leaflet. And that's once your data is in the right format and it's spatial, then you can start, because from the SF object, you know what the shapes look like, and from the census data, it knows what color to make each shape. And then the last step is making it interactive, and with that we use Shiny. So you want to let the user choose, I want to see this year, this demographic section, this variable. You want to let the user control all of those inputs, because there's so many different combinations that you want to let people interact with them.
Can we use ggmap for leaflets also for mapping?
Yes, so if you you can use ggmap and ggplot now to visualize geospatial data. Where leaflet comes in is if you want the kind of panning and zooming, so that's what leaflet is doing. This kind of background tile, and this kind of like all this panning and zooming, that's coming from leaflet. So if you just want to visualize the geospatial data, which I have here. So this is another app I made that we can come to if we have time. But so this is, I think, this is just ggplot with the geom SF for visualizing SF objects. But there's no map, right? Like it's the shape of a map, but like all of the background tiles, it's just plotting the shapes. So ggmap or ggplot, you can do that. But leaflet gives you the full map experience, you could say. So all the mapping, and so sometimes you don't need leaflet, but if you want to do kind of using the map as a map, you need leaflet. Okay. So I guess let's talk about step one now, like wrangling the data. The first step, is really learning the tidyverse. I think that's where this all starts. Like, this book is fantastic. It's freely available online. How many people have seen this book? Okay, great. And that's good, because it's like, I've done a lot of MOOCs and things, but I think this book is really a great place to start. I like the exercises and the solutions that you can find online that other people have submitted. So all of the wrangling data, first you really should learn the tidyverse. So to sort of go to your question of what my data frame looks like, this is like a small piece of it. But eventually you want to get your data frame in a tidy format. So you want each column to be a variable and each observation to be a row. And so for 2011, I think there was basically 288 rows for each district, because each district has 8 water sources and 4 water availability settings, and there's SCST and total for each one, so all of those add up. So for instance, for South Delhi, you have, this is the societal, all other choices would be SCST, demo, total, urban, rural, all sources of the water source. Here would be hand pump. Other options would be like covered well, tube well, things like that. WA, and I've shortened this just to sort of fit, within premises, near premises, away from premises. HH here would be total households, and then EA is electricity is available. So other options are like LA, latrines are available. Then most years have latrines and electricity, latrines but no electricity, neither. So those are all different categories that it breaks it down into. And then you would mutate variables for percentage. So you would, mutate a new variable, divide EA by HH, and you'd get your percentage for electricity.
So you have got district-wise data to start with, and you harmonized them all together and came up with this.
Yeah, so I had, step by step, first combine the different Excel sheets, then start to get them in the tidy format, step by step. But this is sort of the end goal that you want. You want your data to be tidy, because all of the other packages you're going to use whether it's just ggplot or SF or leaflet, they all, are having this expectation that this is how your data will be structured. Does that make sense? So a few tips I learned along the way that probably should have been obvious. District names are not unique identifiers, so that's something probably most people know, but you have to combine the district name and the state name for it to be unique. That trips you up later if you haven't done that. Checking for multiple sheets when reading Excel files, like they were all really pretty good, but for some reason one Andhra Pradesh file decided to break their data into 2 sheets. So I was missing half the districts. I was, like, what happened to half my districts in Andhra Pradesh? But when I was reading in the data, I was only reading in the first sheet, and that seemed to work for almost every case. But, so that's something you should check. And then what I mentioned before, like implicitly missing data. There are no, scheduled casts in the Northeast. So, everything will read correctly, everything will work, but then you have to keep track of like how many rows should I have? Why is that number not matching up? So that's really useful. And this tidyr complete function is, really saved me there. Like, you can tell it basically like, complete my rows based on certain variables. So it was able to generate able to turn my implicitly missing data into like explicitly, like so for every row I should have, whether it's scheduled cast in the Northeast in each district, so they would all be missing, but it's in my data frame at least. So when I go to map it later, it'll appear gray rather than be completely missing. Has anyone used complete before? Yeah, it's really useful. I was really glad to find it. Okay, so now let's assume we have our tidy data frame and everything is good from there. We're in the right format. But we don't have anything to map this with. We don't know what the shapes look like. We don't know what the districts look like. So the next step is joining spatial data. So now we need some shapes. So geospatial data just means polygons, could be points, it could be line strings like points connected. And this is really an excellent book. This is where I learned everything about the SF package and working with geospatial data. It's completely free, it's online, it's open source. They have exercises and solutions. This is a really great place to get started with working with geospatial data. So once you've sort of tried out the SF package and sort of figured out how your way around things a bit, what you're hoping for is something like this. So I have the exact same data frame, but you'll notice in the last column it's a bit cut off. But now I've added the geometry. So now for each district, it's a big long list column. It'll have all kinds of different coordinates. But it now knows what each district's shape is. So just like any other join, left join, right join, inner join, semi-join, you join your 2 objects. You have your spatial data, which has your district names and what they look like, the geometries, and you join that to your census data. So basically, and this is brand new for R. This SF package is pretty new, and what's really nice about it is it's brought geospatial data into your tidy workflow. So previously you couldn't really work with geometry in this kind of data frame way. So SF objects are actually also data frames. The only difference is they have this geometry column.
And for each district or each state, you found same number of data points to form SF. Or it could be like for a single district you found 5 data points, and another district is 4 data points. Is that the case?
What kind of data points?
Like in this scenario, you got data points, different data points, like coordinates or something else, right? So were they of same number, for each of the district, or there were some different numbers?
So I found like a data set that would have 640 districts for each district. Basically, just you need 2 columns. You need the name of the district and the shape.
The shape is in one column.
The shape was in a, I think I originally found it in the SP format. So it's sort of like a list. It's like an S4 object,
Okay.
but you just convert it into an SF object. And then it comes, simple 2 columns. One column has the geometry, one has the name. So the SF package makes working with geospatial data a lot easier because it's not like you don't have to learn an entirely new way of working with data. It's almost like working with a normal data frame. But now we have this together. So now we have like the census data, which will tell us what colors to make each shape, and we know how to draw each shape. So we have those 2 things together. A few things that I ran into. This was really useful. So one problem I had is that the spatial data I found had very different names than the census data. They'd be different in all kinds of different ways. So you have a district South 24 Polygons in West Bengal. So in my census data, it used the number 24, but in my spatial data, it would write out 24. And then you'd have, in census data, it's called Champa district, but in my spatial data, it's like Jungi or Champa. Or, some has hyphens, sometimes it has spaces. And I didn't really know how to, trying to solve that with regular expressions with string operations would be really difficult because, there's so many different cases of why they don't quite match up. So I just Googled and found a Stack Overflow page, and this VWR package, I think it stands for Visual Word Recognition. Has anyone used it? So basically I think what it does is it tries to sound out the word and then ranks every other option accordingly, based on distance. So if you give it a piece of text like South 24 Polygons, and then you give it another vector, like all my other possible choices. So it'll go through every other choice in that other vector and try to sound it out and gives it a score. And then I can just sort for the #1 ranking, like closest sounding piece of text. And often that would be exactly right. And then I'd have 5 or 6 that I would have to fix manually. So that was really a great find. So I'm glad this is out there. And then another thing, simplifying polygons. So you'll notice on the map, this looks pretty good, right? This looks like India, but let me zoom in. So you can see that these aren't quite, now they look a bit comical, they look a bit amateurish, they're not completely defined. So these have been heavily simplified. So I actually, using this MS simplify function, I keep only 1 percentage point of the original, I keep only 1% of the original points in the polygon. So in my original spatial data, it's a very detailed polygon. So it has every little curve and bend. But when you're doing a choropleth like this, and especially if you're on a free hosting tier, there's no way, you don't want them that complex, because it'll take forever to load, and certainly at this viewing point, you don't even see that complexity. It's only when you get down, really far, where it starts to look a bit off, maybe. So depending on your objectives, think about simplifying your polygons, and it's quite easy to do with this function. Any other questions on SF? I mean, there's a lot in that package, and this book I can't recommend highly enough. Takes you through, from not knowing anything about coordinate reference systems and all about geospatial data. All right, so now we have this SF object, we have our data, and we know how to draw it. So the next step is mapping it. So for mapping it, drawing a map, I'm using Leaflet. Leaflet is a JavaScript library for maps, but there's an R interface to it. And it's really well documented. Documentation is here. So they do a very nice job giving you examples and explaining how it works. And that's how you build these interactive maps. And they have specific sections on using Leaflet and Shiny together. So it's easy to get started. And another point of reference, this Abhinav Agrawal, does anyone know him? Heard of him? I don't know. So he has a YouTube channel and he has really nice videos on R. He has a whole series on Leaflet. He has about 20 videos, very short videos, and each of them has a GitHub script with the code where you can find out what he's doing. He also has a very good series on Shiny. So I definitely would recommend his videos to get started. So this isn't my real code, but I'll just give you a taste of the syntax of what Leaflet looks like. Maybe it's a bit small to read. But it uses the pipe operator, just like dplyr. Essentially, you feed Leaflet some kind of spatial object. It could be an SF object. It could be a spatial Polygon data frame, but some kind of spatial object. And then you pipe it different arguments. So you add the tiles. So you use the add tiles function. And there's all kinds of provider tiles that come with Leaflet. I've created a custom tile in Mapbox, but you certainly don't have to do that. But basically, you build this map in layers, like you would with dplyr. So it's like a dplyr pipeline. So after you add the tiles, maybe you add polygons, and you tell it how to fill those what color to fill it, what label names to give it. Then again, you add another layer, polylines. Like these would be my state lines, the state outlines, and then give it a legend. So it's very similar syntax if you're familiar with the pipe operator. And mostly I found with Leaflet just a lot of trial and error. Like there's a lot of argument names like opacity, fill opacity, weight, stroke, highlight options, and just figuring out exactly what all of these controls. But it works pretty well. And there's a lot of documentation explaining, how these things work. A few tips, things I've used, like I had some trouble with the layers. So for instance, I have a layer of shapes, the district shapes, and then I have the lines around each state. So that was a bit challenging, but this add map painting function seemed to do the trick. It's basically you set different layers in the map. So you can check that out if that's something that you're facing. That was a good find for me. I mentioned custom Mapbox tiles. So the background here, there's plenty of good options, but I kind of wanted to take out all of the names that weren't related to India. So I wanted to take out Pakistan, I wanted to take out these city names. So it just would be India, so you would focus just on that and wouldn't be distracted. It was a bit of I've never really done this before, so you'll notice when you zoom in now you can start seeing smaller towns, but at least, at this level it looks nice, I think. What else? So then when you're using Leaflet and Shiny, you get two other kind of tips. One is you can save events. You can save things like clicks, mouse overs, and I've used that with the district. So when I click on a district, I'm it's saving that click, like that information from that click, and then you can manipulate it. Another really important thing, especially when you're working in Shiny, is using Leaflet Proxy. So you'll notice, like when I change something, so you'll notice the background map didn't change. So I'm not redrawing the whole map each time, like from scratch. So the initial map loads, the initial colors load, and then every time I change something, I'm only changing the colors. So I'm only redrawing those colors. So you do that with Leaflet Proxy. And you'll notice like even the state lines, they only redraw if the year changes. So for 91, there's different states. So you'll notice like I only change that when it needs to be changed.
So, like, I guess if some of you want, we can take a washroom or a water break right now.
Okay.
Just like, does anyone want that?
Yes.
Yeah, so just we'll just like resume in 5-10 minutes. That's fine.
Sure. How long has it been going on? Okay.
No, I just like, just in case if anyone wants to.
Sorry, I've been joining on for a long time. I'd probably just go for a few more minutes and then we can take questions. So the last piece is Shiny now. So we have now an SF object, we have our data, we know how to draw the objects. We have a map now, but we want to learn how to redraw that map depending on what the user selects. So that's the last challenge, is putting this together inside an interactive app that other people can use. I think I'll skip this for now, but basically the goal of Shiny is I know some people have already heard of Shiny and used Shiny, so I won't go and I'll assume some knowledge, but it's an R package, but it's really an ecosystem. It's a whole framework for building interactive apps. So without knowing any HTML, CSS, JavaScript, you can build interactive web apps. And the idea is turning inputs into outputs. So in my case, my inputs are like the year, societal cross-section, demographic section, data type, plot variable, these kind of filters. So these are all my inputs, and my outputs are the histogram, the line plot, the map. And so what Shiny does is it gives you a way to turn those inputs into outputs. So how do you go from the user selecting water source here to that map being redrawn? And there's all kinds of control that it gives you to delay those reactions or to trigger outputs, trigger side effects. I think the beginner Shiny is very easy and you can achieve a lot knowing very little Shiny. Like the master level is like something I'm very far from. Like things can get really complicated. Like in this kind of reactive programming, because you're not really giving there's so many things that can happen, that you haven't really planned for, like depending on how the user selects all of these different options. But let me just quickly talk about this directory, like all my pieces. So Shiny apps are going to have two pieces: a UI.R that tells the appearance, a server.R that tells the reactivity. Like how should Shiny create the outputs from the inputs. Typically you have a global.R file, so that's all my functions to how to build the plots. I keep that in a separate file because server.R, otherwise you just want to keep your reactive stuff in there. I have a data folder, and the other stuff just kind of comes with when you put your hosting. I have CSS style sheet, just a bit of extra styling that I gave it. When you're setting up a Shiny app, you choose a layout. There's different sidebar layouts, nav bar layouts. there's different cases for dynamic UI. So, for instance, when I'm looking at electricity and latrines, there's different options for filtering by water source, filtering by water availability. But if I choose water availability and I want to plot that, those options don't exist based on how the data was collected. So you need to update your UI based on some input that the user has made. So there's all kinds of cases of in different situations, tools that they've built to help you deal with these kind of situations. Styling, a few tips, like Shiny Themes is a great package. You can give it a really quick look with like one line of code, adding a nice theme to it. There's all kinds of other ways to style apps. I've chosen this one. There's a whole blog post explaining different options. Shiny widgets, the drop-down menu is not like a default input widget. It comes from this package. And Shiny CSS loaders is really nice because it's nice to give the user something to see, like those red dots. They come from that package, and it's just one line wrapping this around your outputs. I don't want to go into this too much, but basically this is the most complicated part, was like figuring out how to build the logic. Because the difficult part for me was that these levels change based on year. So in 2011 there's 8 different water types. In 2001 there's 6 different water types. So depending on the year, these things have to change differently. And I wanted, when you change from year to year, I wanted these things to select the most appropriate one. So for instance, 2011, they have an option away from premises, but that's not there in 91. So I wanted to tell the app to switch to outside premises because that's the closest one. If 2011 has tap water from treated sources and untreated, but 2001 just has tap water, so figuring out all those relationships, I'm sure it's not the most efficient, but it seems to work. But I know I could improve that, probably. Reactive expressions, just quickly to look at this. This is something much more understandable. Like, you build these reactive objects, basically. So I have the choose district function here, based on year, society, whatever the input, whatever the parameters that are chosen, and it creates this object called district SF. And that object will just stay there, and I can use it in other places. So I'll have a function to draw the map, for instance, and it'll use this district SF object. So whatever this district SF object, this object changes as these things change. So whenever I change the year, this thing updates. And then I'll have a function later to draw the map. And because district SF is updated, then it'll redraw the map. So Shiny is all about like dependencies between objects and knowing which things are out of date, causing other things to update. So here I have my histogram. So, this histogram relies on all of these reactive objects, all of which update based on how you built them. So it becomes this huge tangled mess. I have in the blog post that I'm writing, you'll see the reaction log. So you can pull up basically the reaction log and like how everything is connected, and it's just like a whole tangled mess that probably can be improved. Okay, I'll skip this for now. There's code here for like the district click event. Basically, you have to set it up so like if a district is clicked, if a district is not clicked, save that click, and if nothing is clicked, output like normally. Otherwise, I've got this add x intercepts function. So if there is a dictionary click, you take the regular histogram and you add in the x-intercepts. So something like this is probably too quickly, but that's kind of the idea. Okay, and then these are just two last visualization books. These are really great sources. They're both open source. Both have chapters on geospatial data visualization, and they talk all about challenges with Choropleth, as well as all kinds of other really useful data visualization things. I think I've covered most of these things throughout the talk. So I'll end there. The app, this is the link for the app. It's on the free tier though, so if you try it out and someone else is also trying it out, it might crash. The code is on GitHub, at least the scripts, and this is my website where I've posted most of my work. It's made with Blogdown, another R package, and these slides are made with this R package as well. I think he's sharing it. It's made by UA. So I'll stop there, maybe take questions, and then we can get to Himanshu's talk. Okay, good.
Can you again explain the reactivity part? Like in 1991 there were lesser state as compared to 2011, right? So you would state how you updated the shape of each state. But I could
So
see
for 91 they have a different shape file.
okay.
So when basically I don't know if this is the most efficient way, but I set it up as 3 different SF objects.
Okay, got it.
So I have in my function, first you choose the year. So first you have to choose the right SF object based on the input, and that is associated with a different shapefile.
I thought you have single SF object and you are managing it for 3 other years.
I think that would
That's not possible.
the reason, but I mean, if you still chose, as long as you chose the right, if you filtered the data frame to that specific observation, you can have a different shapefile associated with it. But my problem was that I had different levels, and so like that was really my stumbling block, is why I kept it 3 separate years.
But for each year, number of levels are changing, right?
Yeah.
So that's why you cannot do that in a single data frame.
That
It's a
was
single SF.
that's the way I structured it. I don't. Maybe there's a way to do it, but I didn't know what the pros and cons between like having NA rows, NA observations,
Okay, yeah.
versus like just keeping them separate. So I just put them separate. There was another question.
Yeah.
You are running this app now locally,
Mm-hmm.
but what if I wanted to host this app on a website?
So let me see if it's. So it is hosted at this website.
But this is you're using Shiny apps.
Mm-hmm.
This has its own limitations.
Yeah.
But what if I want to host it on an independent website or an existing web page?
If you want to pay for the hosting, you can.
No, I mean like I have access to my own server.
Okay, we can talk. I guess I'm happy to share. I don't know what to do with it really, because I have a few different Shiny apps, and
I think RStudio server needs to be installed in that server first. Then you can host that from RStudio server application.
yeah, I've only deployed apps on Shiny App Server, so I don't know
So
too much.
it's not a RStudio server which you need to install. Shiny has its server on its own. So you need to install Shiny server first, and Shiny server will give you a path in your server. If you just put in your app.r file or UI or server files out there, it will automatically be hosted. So you don't even need to run RStudio or R command inside your servers. You just need to put in your app.r files in the specified location of the Shiny server.
Thanks.
Can I be a part of ArtConnect?
ArtConnect. Sorry, what is ArtConnect?
It's a social platform for art community.
I mean, like, you can simply, I think, sign up this code there. As far as I know, like, you can sort of take this from here. I'm not entirely sure what exactly it is.
ArtConnect is a social platform for people to share their works.
Okay.
Yeah, I'm happy to have it shared, you know, if other people want
Or to connect
share.
with people who are using it.
Okay, so I haven't explored having done that. So like we'd be happy to sort of have a look into it and like so, I mean, there are a lot of platforms, so I mean that's a new one. We'll probably share it with rest of the companies. So if you have any questions for Sean specifically right now or about the talk, you can sort of ask him right now or take it up with him later. Otherwise, any other questions or any other sort of discussions, we can like take them later on like as soon as Himanshu's done with this session. So in general, like I mean, I'm not sure if you sort of touched upon that, but how long like it would be interesting just to know how long have you sort of been using R? How did you sort of start using it? Like how was the experience?
So I've been on like a 2-year sabbatical, and I was doing completely different work, non-technical work, and I just started learning R maybe about 2 years ago, just MOOCs and things, and so I've never done any kind of formal training, just beyond MOOCs and reading open source books, and yeah, I've just kind of gone that way, and you know, exploring different like packages based on projects that I want to build. So I wanted to learn how to make kind of maps, so then I got into the SF package, and so then I just, you know, got into Leaflet and Shiny. So basically, like now that I have like a sort of intermediate level base, like I try to further my learning like in specific areas through kind of projects. So like I did I think last talk the last meetup I talked on tidy text a little bit. So I had done like a little tidy text project on Monkey Bot speeches. So like I was learning RVest, so like I scraped the Monkey Bot homepage, which had all the speeches there, and you know, did some tidy text analysis of like the most common words and things. So yeah, I guess I did my our learning path has been like starting with MOOCs, moving on to like books, and then little projects.
Yeah, okay, so and about that project, the tidy text one, he also had written a blog which is up. We'll share that link as well. Again, thanks Sean, thanks for sort of
I have.
yeah.
So what if the data, like in this case, you have extracted the data, but what if the data was coming through an API or a live data connection? How would that be different to this? Like,
I'm not sure. I think Himanshu's talk is sort of on that,
okay.
but yeah, I haven't really worked with like API streaming and data. I'm sure it's possible,
Yeah.
but I haven't worked with that kind of data. Oh yeah, I think.
Yeah, you can take questions offline as well.
Thanks.